All right, this is Dr. Sweeney, and this is the third part of 3.1. This is about conditional probability. And so, what I'm going to talk about now is I'm going to talk about this idea of conditional probability. So, simply stated, what conditional probability is it is what happens, okay? What happens when we already know a piece of information about our sample space? Information about our probability. And what it basically means from a mathematical standpoint is when we want to restrict our sample space. Okay? So let's imagine, let's look at an example of this, and then what we'll see is some ways to kind of talk about conditional probability. So suppose that we had sampled 50 students, 27 are females and 23 are males. Of the 27 females, 22 said they liked shopping, and of the 23 males, 12 said they liked shopping. So let's imagine that what we've got is right, our total group. And that's n equals 50. Okay, so we've got n equals 50 people in here. And if we take the 22 plus the 12 who like shopping of our whole group, right? So there were 22 women who like shopping and 22 men who like shopping, or 12 men who like shopping. That's the group that likes shopping. The group that doesn't like shopping will be 5 females, 27 minus 5, and 11 males, 5 plus 11, and so hence that's going to equal 16. Okay? So we have 32 members of our group who like shopping and 16 that do not like shopping. If I think about this from a strict probability standpoint, I'm going to use my notation, and the probability that somebody likes shopping is going to equal 32 out of 50, which is equal to 0.64. Okay? So that's the probability that if I pick from everybody that I get to like shopping. What we're going to do with conditional probability is I'm going to say, you know what if I know about the group that I'm selecting that they are all men or male? Okay? So now what I'm going to do is I've got my group, right? All who like shopping, or all who are surveyed, my total. And that's n equals 50. And now I'm going to separate it out, right? There's the 27 females, and we now have the 23 males. And since what I'm going to look for, and this is how I write a conditional probability, I want to know the probability, okay, that somebody likes shopping, and what we're going to say is that they are given that they are male. Given they are male. So our new sample space is going to be this thing over here. Okay? So now we're only going to be looking at our 23 males. So now our new sample space is the n equals 23 males. And of that grouping, right, we've got some different numbers. We had 12 that said they liked shopping. And that means 11 said they did not. For the conditional probability, we're going to say this condition, this is my new total. So my new total is going to be the 23 males, okay? And those that like shopping are only going to be chosen from the males. We are not going to, so they're going to come from here, okay? They're going to be chosen from the males, so it's going to end up being 12 out of 23. Which is 0.522. And there we go. So that's how conditional probability works. Originally, we have the entire set, like in this case, all of the students that we asked. When we do a conditional probability, which we denote here utilizing the total on the right-hand side and the desired result from the total, we're going to make our total this new amount, or this new what we call the condition. Okay, so that's called the condition. So now that's the males. Okay, that's the males. And those who like shopping, we're not going to worry about the females. We're only going to concern ourselves with the males. So consequently, that's why we ended up with the 12 males who like shopping over the 23 total males. Okay? And that's how we work with conditional probability. So let me give you a different example. Suppose that we wanted to know the probability does not like shopping. And in this time, we're going to say given that the individual is female. Well, now we know that we have 27 females. We're only going to be picking from this grouping. Okay? We got the 27 females. And of those 27 females, we know that, in fact, 5 of them do not like shopping. That was what we got before. So it's now 5 out of the 27. Okay? 22 of them like shopping. That means 5 of them did not like shopping. So 5 out of 27 is equal to 0.185. Okay? When I see a probability, all right, in which I am not actually given a condition, in which I don't utilize the word given, or I don't have this line here, then I know that I'm going to be picking out of the total. However, once I know a piece of information, say for example that the group that I'm picking from is male, now I'm going to restrict my sample space to only the males and figure out how many of them in this case like shopping out of the males, right? If on the other hand, say for example I have something different over here on the total, that tells me what my new sample space is. So my sample space in these cases are 2 different groups. Okay? One is going to be the males in the study, and the other is going to be the females. And in this case, we're going to ask those who do not like shopping from the females. So these are also the do not like shopping. They're only females as well. So that completes our little discussion on conditional probability.